Welcome. Today, we are going to totally demystify artificial intelligence. I know it can feel like this massive, complicated topic, but trust me, we're going to break it all down into simple, clear concepts. So whether you're studying for an exam or you're just curious about the tech that's literally changing our world, let's just dive right in.
So let me ask you this. Have you ever wondered how YouTube does it? You know, you watch a couple of videos and bam, suddenly your entire feed is perfectly tailored to exactly what you like. It seriously feels like magic, but it's not. It's actually a really powerful form of AI at work, and we are going to pull back the curtain and see exactly how it functions.
So here's our game plan. First, we're going to nail down what AI actually is. Then, we'll look at its two main families and see where it's already a part of your daily routine. After that, we'll get into the good and the bad, the pros and cons, and finally, we'll peek under the hood to see how an AI actually thinks. All right, part one. What is artificial intelligence? Look, before we can get anywhere else, we have to build a solid foundation. So let's start with the most fundamental question there is. What is this thing we call AI?
Okay, at its absolute core, AI is all about making machines smart. It's about giving computers the ability to think, to learn, and to make decisions in a way that kind of mirrors how we humans do it. This one idea, right here, is the bedrock for everything else we're going to talk about. And you've probably heard the terms AI, machine learning, and deep learning thrown around, maybe even used interchangeably. But they're not the same. The easiest way to think about it is like this. AI is the big, overarching field. Inside that field is a specialty called machine learning, or ML. And then tucked inside that is an even more specialized technique called deep learning. They're like nested boxes, each one a part of the one before it.
So let's zoom in a little on machine learning. This takes us right back to our YouTube question. See, ML systems learn from old data. The YouTube algorithm looks at everything you've watched, it learns your tastes, and then it makes a really good guess about what you'll want to see next. And here's the kicker. Nobody is sitting there programming it to suggest, that specific funny cat video. The machine is figuring it out all by itself.
And then deep learning takes things even one step further. It uses these really complex structures, they're called neural networks, to learn from just massive amounts of data. A perfect example is your phone's Face Unlock. The first time you set it up, it learns your face. But it keeps learning every single time you use it, recognizing you in bad lighting, with a different hairstyle, whatever. That's deep learning right there in your hand, finding patterns on its own.
And this whole field didn't just pop up overnight. It has a pretty rich history. The journey really began way back in the 50s, with Alan Turing asking that simple yet huge question, can machines think? From there, we hit these major milestones, like IBM's Deep Blue beating a world chess champion, to Apple giving us Siri, and of course, to the mind-blowing AI like ChatGPT that we can all talk to today. It's been an absolutely incredible evolution.
Okay, on to section 2. So we know what AI is, but how do the experts actually classify it? Well, it turns out there are two main ways to slice it, by what an AI can do and by how it actually works.
First up, let's talk capability. And this is a really important distinction to get. Practically every AI you and I use today is what we call narrow AI. It's brilliant at one specific job, like playing chess or suggesting a song. The other two categories you hear about, general AI, an AI that could think like a human across lots of different areas, and super AI, something smarter than all of us, well, for now, they're still just concepts. They don't exist yet.
The other way to sort AI is by how it functions. Think of it like a ladder. At the very bottom step, you have reactive machines. They only see what's happening right now. They have no memory. Most of what we use is the next step up, limited memory AI, like a self-driving car that remembers the speed of the cars around it for a few moments. Now the higher rungs, theory of mind, which could understand emotions, and self-aware AI, which would have its own consciousness. We're not there yet. That's still in the realm of research and, honestly, science fiction.
Moving on to section 3. So, we've talked theory, but where does this stuff actually show up in the real world? You'd probably be pretty surprised to find out just how much AI you're already using every single day.
Seriously, AI is already woven into the fabric of our world. In a hospital, it's analyzing X-rays to help spot diseases earlier than a human might. In your bank, it's the silent guardian angel spotting weird transactions on your credit card. When you're shopping online, it's what recommends that thing you didn't know you needed. It's even in the video games we play, making opponents smarter and the game more fun. It's just everywhere.
Okay, section 4. Let's be real.
No technology this powerful comes without some strings attached. So to get the full picture, and this is super important for any exam, we have to look at both sides of the coin. It's time to weigh the pros and cons on the AI balance sheet.
So, on the plus side, the benefits are huge. AI systems can chew through enormous amounts of data with a speed and accuracy that's just not humanly possible. They can work around the clock, 24/7, no coffee breaks. They cut down on human error in boring, repetitive tasks, and they can even do jobs that are way too dangerous for us, like defusing bombs or exploring the deep ocean.
But there's a flip side. All that amazing automation could lead to people losing their jobs. These systems are also incredibly expensive to build and to keep running. And at the end of the day, they don't have real emotions or creativity. But maybe the most critical point is this: an AI is only as good as the data it learns from. If you feed it bad, biased data, you're going to get bad, biased results. And that opens up a whole can of worms when it comes to ethics and security. All right, our final section. Let's get under the hood. We know what AI is, we know what it does, but how do you actually build one of these intelligent systems? How does it see the world and then decide what to do? This leads us to the classic question, the one first asked by the father of computer science himself, Alan Turing. I mean, if we're building machines that are supposed to be intelligent, how do we even measure that? How do we know if we've actually pulled it off?
And that brings us to the famous Turing test. The setup is actually pretty simple, but it's brilliant. You've got a human judge who's texting with two mystery participants. One is a person, the other is a machine. If, after a bunch of questions, the judge can't consistently tell which one is the machine, then the AI is said to have passed the test. It's a test of imitation. Can it act human enough to fool a human? So to build a system that can act intelligently, we start with a basic building block. In the world of AI, we call this an agent. Don't let the word scare you. An agent is just anything that can sense its environment, using something like a camera or a microphone, and then do something in that environment, using things like wheels or a robotic arm. It's the fundamental concept. And to design an agent, we use a simple blueprint called the PAAS model. It's super handy. Let's take a robot vacuum. P is for performance. How do we know if it did a good job? Well, how clean is the floor and how long did it take? E is for environment. That's the room, the floor, the dust, the furniture. A is for actuators. Those are the parts that do stuff, the wheels, brushes, and the suction motor. And S is for sensors. That's how it sees the world, the dirt sensor or the camera. You can break down every single AI agent, from a simple vacuum to a complex self-driving car using this model. And there you have it. We've basically covered the entire map of AI. We started with the what, we explored the different types, we saw it in the real world, we weighed the good against the bad, and we even looked at the basic recipe for building an intelligent system. These are the core concepts that everything else in AI is built on.
And that leaves us with a huge question, one we're all going to have to grapple with. As these systems get smarter and more autonomous, who's responsible when they mess up? If a self-driving car gets into an accident, who's at fault? The owner? The programmer? The company? This is one of the biggest ethical challenges we face in the age of AI. Thanks for joining me for this breakdown.